Good morning, dear student. I am Tarungal. Today I am discuss about magnetostatics. Magnetostatics. So, what is magnetostatics? Magnetostatics generally magnetism in which the magnet is present. Magnetism, magnetism, magnet have poles which is north and south. In electrostatics, we know the charge have isolate, but in case of magnetism, no pole have isolate. So our aim is seen in electrostatic and magnetism. What is difference? So difference between electrostatic and magnetostatic. In electrostatic, the charge are stationary, but due to moving charge, both electric and magnetic field present. So electrostate in electric field only stationary charge present, but whenever the charge is moving, so we have say the electric and magnetic field both are present. So our motive is what? Our aim is see how is a magnetic field effect on moving charge. So in magnetic field, when any charge moving with velocity v is direction perpendicular or initial velocity or final velocity. So when is charge particle moving with v velocity in field V, so this charge Q experience a force known as Lorentz force. So Lorentz force comes due to moving charge in magnetic field with v velocity. So in simply we have Lorentz force written as when a charge q in magnetic field B moving with velocity v, so charge experience a force which is known as Lorentz force, is mathematically written as q v sin theta. So this force is generally depending on the velocity of the moving charge, also depend on the magnetic field B. So this force, this Lorentz force F is depend on the charge for particle moving in field B, also depends on magnitude of magnetic field, and also depend on the velocity of the moving particle, and also depend, and this force will be depend on the direction, angle between angle and direction of q. So generally we have Lorentz force written in vector form is q v cross b. So direction of force is perpendicular to the plane containing of velocity, a charge with velocity v moving in magnetic field B. So direction of this force is also perpendicular to the, if this is magnetic field direction B, this is direction of charge q, so this is the perpendicular to the B and charge direction q. So these all are perpendicular to the each other, q perpendicular B perpendicular R. Now we have seen some situations when the charged particle moving, and some situations where charged particle q moving with velocity v barabar 0. So force acting on the particle is F barabar constant. In this situation, the charge q is stationary. Second situation, when charge q is parallel to the magnetic field, means the charge q is similar to the direction of magnetic field, so angle between magnetic field B and charge is 0 degree. Theta equals to 0, so sin 0 0, so force acting on particle will be 0. In another situation, when charged particle move perpendicular to the magnetic field B, in this situation, angle between charged particle Q and B is 90 degree. So in this situation, the force acting on this particle is maximum F बराबर QV and particle move in circular orbit. Now again we have seen the motion of charged particle. We have seen when charged particle, motion of charged particle Q in B. So what is radius and time period of moving particle in field. So we have seen when the charged particle move in magnetic field is perpendicular. Charged particle mu Q moving with v velocity perpendicular to the magnetic field B. In this situation, the total charge, total work done on this moving particle is 0. It means the velocity so kinetic energy of moving particle is constant. Velocity of moving particle is constant. So velocity of moving particle is constant. So essential condition, essential situation when a particle moving in a magnetic field with constant velocity which is condition of circular motion, and in condition of the circular motion we have seen the force acting on this charged particle V is always perpendicular to the direction of velocity. In each point, the direction of force is always perpendicular to the velocity. So, in each case, constant velocity, moving particle experience a force is toward to center. So this condition is mv square upon r बराबर qdv force. This is the centripetal force. qdv is the centripetal force maximum. So now we have summarized mv square upon r बराबर qdv. So r बराबर v is cancel out. r बराबर mv upon qv. This is the radius acquired by the moving particle in magnetic field. Radius acquired by moving particle in magnetic field B. Also we have to find the time period and velocity and frequency of the moving particle in magnetic field. So frequency is 1 upon time period. and 1 upon time period is P बराबर 2 pi upon V. So R is 2 pi upon V into R. R is mv upon qv, and V is which cancel out. So 2 pi m upon qv. This is the time period of the moving particle in magnetic field. Also 1 upon T बराबर frequency, and this is the qb upon 2 pi m. This frequency is the moving particle in magnetic field. Move is depend on the magnitude of charged particle, also depend on the magnetic field, also depend inversely proportional to the mass of the charged particle. And here we have seen the radius of the charged particle is depend on the velocity, also mass, also q, and magnetic field. So thank you so much. Watch and